Many processes, whether they involve process control or machine control, can be defined as a sequence of steps, with the transition from step to step dependent upon enabling conditions such as process events or time. Control of such processes is called sequential control or sequence control, and the program that provides this control is called a sequencer. A sequencer is always executed starting with an initial step or multiple initial steps. This is followed by additional steps as needed to complete the sequence. Each step includes actions that control an actuator or internal element. While a step is executing these actions, it is referred to as an active step. Between sequential steps is a transition with enabling conditions that must be satisfied before the next step can become active. A sequencer can have alternate branches which permit only one path to be followed, and/or simultaneous branches which are activated at the same time. A branch can be terminated with a branch stop as shown at the bottom of sequencer 1. A branch can also include jumps. A jump, as shown at the bottom of sequencer 2, directs action to a step. Sequencers like sequencer 2 without alternate or simultaneous branches are called linear sequencers. Before you create the program for a sequencer, you should design the structure of the sequencer by breaking down operation into steps. To understand this better, consider a simple drilling process based on the equipment and the accompanying graphic. For this application, you must start and stop the process, clamp and unclamp the workpiece, raise and lower the drill, and turn on and off the coolant, all in the right order at the right time. The accompanying graphic shows an example of the sequencer steps and transitions for this basic drilling process. Because this is a repetitive process, note that after transition 6 there is a jump to step 1. Keep in mind there are additional steps in the design process as described earlier in this course. So the process should have previously been flowcharted and the I/O and control devices selected. Graph is a programming language referred to in the IEC 61131-3 standard as Sequential Function Chart (SFC) that is designed for sequencer programming. Graph is integrated in Step 7 Professional as S7 Graph, which is fully compliant with the IEC 61131-3 standard. With S7 Graph, you can clearly and quickly configure and program sequences for control with an S7 automation system. The process is divided into individual steps, each of which has its own functional scope. The sequences are displayed graphically. It is easy to create a sequencer structure without programming expertise as you simply arrange S7 structure elements to form a representation of the sequencer. Text and images can be added for documentation. The actions to be executed are defined in each step. Progressing to the next step is controlled by the transitions with step-enabling conditions. Transition definitions, interlocks, and monitoring functions are designed using FBD or LAD. Like other FBs, a graph FB is called from an OB, FB, or FC and uses an instance DB to store its data. A graph FB can include an optional block comment, one or more sequencers, and optional permanent instructions. Permanent instructions are block calls and conditions that must be satisfied at more than one point in the sequencers. Permanent instructions can be located before or after the sequencers and are executed once per PLC scan regardless of the state of the sequencers. Within the FB, each step and transition in a sequencer is defined. This includes the following items: an optional step comment that describes the step, actions, which are instructions or events that are executed from top to bottom while a step is active. The actions are defined in the step's action table. Conditions, which are logical conditions programmed in LAD or FBD that can influence individual actions of a step, the entire step, the enabling of the next step, or the entire sequencer. Conditions occur in interlocks, supervisions, and transitions. An interlock defines conditions that influence the execution of actions. If the logic of the conditions is satisfied, the actions combined with interlocks are executed. A supervision defines conditions for monitoring a step that influence the way the sequencer passes control from one step to the next. A transition defines the conditions that control the activation of the next step or steps. The actions for a step are defined in the action table for the step. These actions are executed from top to bottom when the step is active. The address affected by an action is shown to the right of the action in the table. There are three categories of actions: standard actions, event-dependent actions, and actions with counters, timers, or arithmetic. Instructions used in standard actions are shown in the accompanying graphic. These instructions are used to set and reset bits in the specified address or to call a function block. The letter C, added immediately to the right of the instruction, indicates that an interlock condition must be satisfied before the instruction is executed. An event-dependent action is executed when a specific change occurs, such as when a step is activated or deactivated. State changes associated with a specified supervision, interlock, message, or registration can also trigger an event-dependent action. An action can also have a timer, counter, or arithmetic instruction. Timer and counter instructions are always event-dependent. Arithmetic instructions can be event-dependent, but can also be set up to be independent of an event. Conditions are LAD or FBD instructions. The result of logic operation, RLO, of these instructions can affect the enabling of a step, a specified step action, the entire step, or the entire sequencer. Conditions occur in the following areas: transitions, interlocks, supervisions, permanent instructions. The transition follows a step and controls the activation of the next step. If the transition logic is satisfied and the preceding step has been deactivated, the next step can be activated. An interlock is a programmable condition that affects the execution of a specified action. If the logic of the conditions is satisfied, the action is executed. If the logic of the conditions is not satisfied, the action is not executed and an interlock error is signaled. Supervision is a programmable condition for monitoring a step that influences the way in which the sequencer passes control from one step to the next. If the logic of the conditions is satisfied, a supervision error is signaled. If the logic of the conditions is not satisfied, no error is signaled, and if the successor transition is satisfied, the sequencer passes control to the next step. A program supervision is indicated by the letter V at the bottom left of the step. Permanent instructions, as previously described, are conditions and block calls at the start and/or end of the sequencer. This chapter has covered the following topics: structured control language SCL programming and graph programming. The concepts and terminology discussed in this chapter will be useful to you in furthering your knowledge of Siemens PLC programming.